For this function, we're going to find the vertex first, and the vertex is going to help us determine whether we have a maximum or minimum value at that point. And we're also going to use the vertex to help us find the range, and then we're also going to use the vertex to help us find the intervals of increasing and decreasing. So everything starts with the vertex. Now the easiest way to find the vertex is using a vertex formula. And the x value of the vertex, in fact, a lot of books use h for the x value. And that formula is negative b over 2a. So all you do is substitute your a and your b into the formula. Now a is the number in front of x squared. If you don't see a number, it's always a 1. B is the number in front of the x, which is a negative 2. So that means I'm going to put the negative 2 in this parentheses and 1 in this parentheses. And I'm going to simplify it. A negative negative is a positive 2. 2 times 1 is 2. So that means the x value of our vertex is 1. Now we need to find the y value. Law books use k. So to find the y value or the k, what you basically are going to do is find f of 1. And to find that, I'm going to take the original function, and everywhere we have an x, I'm going to put a 1. And so you get y equals 1 minus 2 plus 6. And 1 minus 2 is negative 1 plus 6 is 5. Now, it doesn't hurt to go ahead and use your calculator if you want to. So I'm going to type this in as if I'm going to graph it. And it looks like that the vertex is 1, 5. Now what I can do is I can look at the table and see if there's any characteristics going on. You see that 1? See the y value? It just confirms that the y value is correct for x equals 1. If you notice, 6, 9, 14, 6, 9, 14, that kind of is a way to verify that 1, 5 is your vertex, because you get the same y values on the left side and the right side of that vertex, which makes sense. You can also do trace 1, enter. Sometimes it's a decimal that you can't see, so you can always use the trace feature. And then you can also do this. If you go to second trace, this is a minimum. A minimum looks like this, and a maximum looks like that. The reason why we know it's a minimum from the equation is because the a is a positive value. Anytime the a is a positive value, or the coefficient of x squared is positive, it's always a minimum. If it's a negative, then it's a maximum. You can go down to the minimum or just hit 3. You need to do left bound, right bound. So I just move it to the left and hit enter. And to the right, I can choose like 5. So you can move it, or you can just type in a number and hit enter. And then guess. You'll see something that looks like 1, 5. Anytime you see that kind of number, it actually is a 1. So there's all kinds of ways of looking at it. So that just confirms what we already know. The vertex is 1, 5. And I'm just going to look at this graph. I don't really care too much about the grid, the XY plane. The only thing I care about is this 1, 5. Now we can find out whether there is a maximum or minimum. And since we already said that it looks like a valley, that there's a minimum, the minimum value is y equals 5. It's always y value. And then a lot of books will want you to say at x equals 1. But the minimum value is y equals 5 at x equals 1. And we want to find the range. The range is not so bad once you have the graph. Range is the lowest y value, the highest y value. Once again, range is the y values. So, what's the lowest y value? Well, it's a 5. And what's the highest y value? Well, it goes forever up. So that's infinity. Is the 5 included? Yes, it is. It is a part of it's a part of a point. It's the y coordinate of a point on the graph. So we include it with a bracket. And then the last thing we want to find is, where's the function increasing and where's it decreasing? So what you want to do is kind of think of this as being cut in two at the vertex. That's terrible. That's absolutely terrible. And so when we do the increase and decrease intervals, we don't look at the y value, we don't look at the x values. So increase and decrease is x values. Max and min are y values. Range is y values. So we're looking at the intervals for x. And if you look at it, it's coming from all the way from the left. It's coming from negative infinity. And from negative infinity to that x value, we cut it off at 1. So from negative infinity to, this is all big 1. From negative infinity to 1, the graph is going down. So that's a decrease. So it's decreasing from negative infinity to 1. Anytime you do intervals, increase and decrease, use parentheses no matter what. And then from 1 to positive infinity, it's going up. Always use parentheses. 1 to infinity. And that's it. In this example, we're going to find the vertex. We're going to determine if there's a max or min. We're going to find that value. We're going to find the range. We're going to find intervals of increase and intervals of decrease. Everything starts with the vertex. So, I don't really want to use V for vertex. I want to use H or K. H for the X value and K for the Y value. And I'm going to use the formula negative B over 2A. And I'm just going to do this without a calculator. I may use a calculator to graph it, just so you can see how the function will look. But we know that since A is a positive 3, hopefully we know that the graph looks like this. It's a minimum value, it has a minimum. And then B is 24. So we're just going to substitute those in. B is 24, A is 3. So you have negative 24 over 2 times 3 is 6. So you have x equals negative 4. And then for our k value or our y value of the vertex, we're just going to substitute negative 4 in everywhere we have an x. These numbers could be kind of big. Negative 4 is 16, 16 times 3 is 48. 24 times 14, what is that? Negative 96. I don't want equals there. Negative 96 and then minus 12. So we get y equals negative 48 minus 12, negative 60. So our vertex is negative 4, negative 60. And it never does hurt to use a graph, a calculator to confirm. 3x squared plus 24x minus 12. Gonna graph it. You can see it's a minimum. You can't see the bottom of it, but you know it's there. I'm gonna hit trace negative 4. This is my preferred method to check the vertex. Yeah. And we know it's a minimum. So we need to find the max or min. We know it's a min. If it has a min, we need to find that value. We need to find the range. So the minimum is the lowest y value, which is negative 60. So y equals negative 60 at x equals negative 4. And then for the range, let's just go ahead and draw a generic graph. So to find the range, what's the lowest y value? The lowest y value, because range is y values, is negative 60. And what's the highest? Well, it goes up forever in both directions. That's infinity. Infinity you can include, so it's parentheses. Negative 60 you can. Bracket. And then we need to determine where it's increasing and decreasing. When you do increase and decrease, you're looking only at the x values first off. As far as the interval goes, you're actually looking at the graph, which is a graph of y values. So I'm going to not mark it off. Mark it off. And so it's the x value there is negative 4. This is all one big negative 4. So it's going down from negative infinity to negative 4. It's decreasing. I always use parentheses. And then from negative 4 to positive infinity, the graph is going up. So it's, or negative 4. Maybe I didn't say negative 4. But negative 4 to positive infinity, it's going up. So that's an increase. And we're done. Let's find the vertex, max min value, range, and intervals of increase and decrease for this function. Now, since we know that a is a positive value, that means that it's going to have a minimum, and b in this case is -20. Let's find the vertex. We're going to use negative b over 2a to find the x value. B is -20. Do you see why I use parentheses? It's for signs. Because the negative makes that a positive 20. And 2 times 2 is 4. Which means that x is equal to 5. Now to find the y value, we find alpha of 5. So everywhere we have an x, we put 5. And so 5 times 5, do the exponent first. 25 times 2 is 50, minus 100, plus 52. Negative 50 plus 52 is 2, so the vertex should be 5, 2. Never hurts to check with the calculator. I like to type it all in at once, even though I could type all this in a plain screen. I like to look at the graph also. It just confirms everything that we've already suspected. Looks like 5, 2. We always hit trace, 5, enter. Yep. So we're good to go. Someone draw the graph. It's a minimum. Vertex is 5, 2. So it does once again have a minimum. It's y equals 2 at x equals 5. The range is the y value. The lowest y value to the highest y value. So it goes down to 2 all the way up to positive infinity. 2 is included. And then we're going to look left to right to see what's going on for the increase and decrease. We never use the y values for increase and decrease. So we're coming from negative infinity and the graph is going down. So from negative infinity to 5, the graph is going down. So that's a decrease. And then from 5 to positive infinity, the graph is going up. So that's an increase. And we're done. For this example, we're going to find the vertex, max min, range, increase and decrease. Since a is a -4 because it's in front of the x squared, this one is going to be an upside down u. I'm not sure what happened just then. Seems to happen more than it should. But it is an upside down u. That's a crazy looking upside down u. So that means it has a max. And then b is -12. So we're going to use our vertex formula. X equals -b over 2a to find the vertex. B is -12 and a is -4. I always use parentheses. Negative is a positive 12. And 2 times -4 is -8. Which means our x value is going to be our fraction. Or we could use a decimal. -3/2. Now to find the y value of the vertex, we're going to find alpha of -3/2. That just means you take the -3/2 and substitute it in. So -4, -3/2 squared minus 12 times -3/2 plus 9. Let's see if we can do this one by hand. Let's see, -3 over 2 squared is 9 over 4. Those 4's will cancel, leaving -9. And negative is a positive. 2 goes in 12 6 times. 6 times 3 is 18 plus 9. those cancel, it leaves 18, so our vertex should be negative 3 halves, comma 18. Let's use a calculator to check. So let's type in negative 4x squared minus 12x plus 9. Notice it's going up and coming back down. I like to hit trace because the graph won't help us out at all. The table I mean. So let's type in negative 3 divided by 2 and hit enter. And what do you know? Looky there. I was correct. Okay. So that means is we have an upside down U. You know, like I was going to sing a Bismarcky song, but I'm not. I can't sing. So we got a vertex. So what that means is we have a maximum this time. The maximum is the y value. Y equals 18. X equals negative 3 halves. The range, how far down does it go? Well, it's going to negative infinity. What's the highest y value? The highest y value is positive 18. Negative infinity is not included. That looks like a weird flower. And 18 is, so it's a bracket. And now we need to do max and min, or increase and decrease. So I don't care about the y values when I do increase and decrease. I just look from negative infinity to positive infinity, left to right. Negative infinity to positive infinity. So from the left, the graph is going up. So it's increasing from negative infinity to, what's that x value that's going up? Negative 3 halves. Always use parentheses for increase and decrease. So from negative 3 halves to infinity, the graph is going down. And we're done. Ball is thrown directly upward from a height of 8 feet, and this is the function we're going to use. Determine the time when the ball reaches its maximum height and find the maximum height. So we need a time and a maximum height. Keep in mind that t is time and s is height. So we're taking our function and since we have a t squared, it's a parabola. Either looks like that or looks like that. Since the a, the leading coefficient or the number in front of the t squared, is a negative, that means it is a maximum. And that point is the vertex. So the maximum is the vertex, or we can use the vertex to find the maximum. So what that basically means, all this is saying is find the vertex. And so to find the vertex, we need to find the, normally I would say x value, but in this case our x value is a t, which is going to be the time that we're looking for. That's the time when the ball reaches its maximum height. So to find that, we're going to use negative b over 2a. Now keep in mind that a is negative 16 and b is 28. So we're going to take those numbers and substitute them in. B is 28 and a is negative 16. We get t equals, notice the negative and negative divided, that becomes a positive. That becomes 28 over 32, and that reduces down to 7 over 8. Now we want to find the s value, or it's actually the y value, but in this case that's our s, and we want to find s of 7 over 8, which means everywhere we have a t, we put 7 over 8. And you could use decimals. I'm just using, and a lot of times it may say use decimals. If it does, then you use 0.0875. I'll use a calculator here in a second to show you. all that. Seconds. And on this one, to save time, let's just use a calculator. I'm going to do it in terms of fractions, but you can easily use that decimal. Here's what I'm saying. 7 divided by 8. It is 0.875, in case you're wondering where I got that number. So let's just type this in. A negative 16, parentheses, 7 divided by 8, close, squared, plus 28, open, 7 divided by 8. Once again, you could be using 0.875, plus 8, math, enter, enter. And we get 81 over 4, which is about 20.25. 81 divided by 4. See that? I think that's in feet. Yeah. So that is the maximum height. And we can always use your calculator to verify this, looking at the graph. So go to y equals negative 16x, I have to use an x, squared plus 28x plus 8. Graph. What's the maximum? Watch this. I'm going to just hit second trace, use the maximum feature 4, and then I'm just going to use, I think it's 0.875, which is between 0 and 1, so let's hit 0, enter, 1, enter, enter again. See that 0.875 and the 20.25? Checks out. Everything checks out. So we're good to go. On this example, we're going to use this function to find the rocket, find its maximum height and how long it takes. First we'll find out how long it takes, which is the time, t, to reach its maximum height, and we're going to find that maximum height, which is h. And the way we do that is, it's actually a vertex problem. If you type it in, negative 16x squared plus 168x plus 3, and we graph it, and you may not be able to see the graph. See if we can do anything under the zoom. Normally there's a zoom fit that would work. Let's see what this does. Let's do that. Does it help any? A little bit. Let's do that one. Yours probably has a zoom fit. It's better to use zoom fit if you have one. Let's just do this. Sometimes you can change the window range, like negative 100, enter, positive 100, enter, 10. Let's see, and then let's go ahead and change those to negative 100, enter, 100, enter, 10. Well, sometimes the calculator isn't always the best thing to use. Zoom 6 takes you back to the regular window. That just shows you don't always depend on the calculator. Depend on your math. So, notice this is a quadratic equation, and we have an a, which is negative 16 because it's in front of the t squared. We have a b, which is 168 because it's in front of the t, or the x. Since this is a negative, that means, and it's a square, that means the graph looks like this. So it is a maximum up there. And that max is a vertex. So what that means is, we need to find our t value using the vertex formula, negative b over 2a. T is the time, so that's the first thing we want to find. And we've already got our b and our a, so let's go ahead and substitute those in. B is 168, and t is negative 16. When you do negative divided by negative, you get a positive. Well, I'm going to do this by hand, even though you can type it in calculator. I'll do that here in a second. 2 goes in 168. Well, that's just so bad. Let's just do this. 168 divided by 32, because 2 times 16 is 32. And that reduces. 4 goes in 16, 4, 2, 4, 3, 8, and that reduces down further. So let's reduce it down further. 2, 21, and 4, which is exactly 20.25. Not leaving anything out, showing you exactly what I'm doing. Now, I easily could have just taken my calculator out and typed in 168 divided by parentheses 2 times 16, enter. 5.25. Where did I get 20 at? That's just crazy. Always check. Hey, always check. And then I can convert that to a fraction, which is 21 over 4. Now, I need to find the y value, or in this case, the h of t value. That's going to be our maximum height. You can use either the fraction or the decimal. I'm actually going to use the fraction, because some systems want you to use or put the answer in fraction form, if it so happens to be a fraction. So I'm just rewriting this function, replacing the t with empty parentheses, because inside those parentheses we're going to use 21 over 4. And then if it were me, I could use a graphing calculator. I'm going to type it in, just as it is. Negative 16 parentheses 21 divided by 4 close parentheses squared plus 168 open 21 divided by 4 close plus 3 math enter enter. Nice number. 144. So what that means is that this is the maximum height that is achieved after 5.25 seconds, if I got the units correct. Yeah. And that's it. Let's consider this example. And you'll notice it involves revenue and cost and profit. Now, to find profit, you take the revenue and you minus the cost. So in this example, we're going to take 770x minus x squared, put that in parentheses, minus the cost, which is 2200, plus 50x. And then we're going to subtract those. But first, I want to get rid of the parentheses. So I'm going to distribute the minus sign to the second parentheses, and we get negative 2200. And then negative times the positive is a negative 50x. Then we're going to combine our like terms. Start the x squared, the negative x squared, it comes first. And then we have 770x minus 50x, which is a positive 720x. And then minus 2200 remains. So that's our profit. Now, when you look at the word problem, it says maximum, determine maximum profit, and then the number of items that must be produced and sold to obtain maximum. Anytime you see maximum, that means vertex. So what we're going to do, we're going to find the vertex. So we're going to let x equal, or use the formula, vertex formula, negative b over 2a. B is 720. A is negative 1. Because the number for the x squared, you don't see it. It's actually a 1, negative 1 in this case. So it's negative 720 over negative 2, which is a positive 360. So stop right there. The number of items that must be produced and sold to obtain the maximum profit, well, that's what x represents. If you read the problem, x represents the number of items produced and sold. That's what the x represents. And that's what we just found. So this one is 360 items. Now we need to find the maximum profit. And that's where we use the profit function. So I'm going to come down here and actually find that. We're going to find P of 360. So everywhere you have an X, you put 360. And if you get a negative answer, it means you did something bad or wrong. So let's take out our calculator. I'm going to move it over. Let's type it in as we have it written down. Negative 360 squared plus 720 parentheses 360 minus 2200. We get that answer 127,400. Well, that's the answer up here. The maximum profit is $127,400. Now consider this example. You have a rancher who wants to build a fence. Now part of the fence is the river, so it means we don't have to worry about this part. It's already enclosed with the river. But he wants to cut the fence in two, so we have that width, and that width, and this one length. So what we're going to do, we're going to use the perimeter to help us find the largest total area that can be enclosed. So when it says largest, that's the same as maximum, that's the same as vertex. In order to find the vertex, we need a quadratic equation. So we need to maximize A equals length times width. But before we can do that, we gotta look at the perimeter, because that's 450 yards of fencing is available. So that's the whole perimeter, or whole amount of fence needed. So we're going to fence in these three widths and that one length. Remember, the other length is the river. So what I need to do now is solve one of these variables, or solve this equation for one of the variables, so I can substitute it into there, so I can find the vertex of the area, or this area equation. Now I could solve for W, but that 3 means I'm going to have a fraction at the end, and I don't want to deal with a fraction. So since L is all by itself, I'm going to solve for L, because it's easier, by subtracting 3 W. And what results is I get L equals 450 minus 3W. So what I'm going to do, I'm going to take that, what that L is, which is 450 minus 3W, and replace it for the L here, and then I still have this other W. So I just substituted this for L. That's all I've done. So now I'm going to work with this equation. I'm going to distribute the W. And when I do that, I get 450 W minus 3W squared, which is the same as negative 3W squared plus 450 W. So now I have my quadratic equation where I can find the vertex. Now it says what is the largest area that can be enclosed. So what I want to do, I want to use the vertex formula, which is x equals negative b over 2a. Now the x is actually a w, so I'm going to find w. B is in front of the w, so that's negative 450 over 2 times the a. Well, the a is negative 3, and so that results in negative 450 divided by negative 6. If you're ever not sure, take out your calculator and type in what it is. Negative 450 divided by negative 6. We get 75. So 75 feet is our width that's going to give us maximum area. Now here's the thing. I don't need the length. It's not asking for the dimensions. Or maybe I do. Since it's asking for the largest total area, and the area is length times the width, that does mean that I do need the area. So here's what I was getting at. If it asked for the dimensions, then I would find the length using this. Got that? And then I can multiply that answer times 75 to find the area. Or, since it's only asking for the area, I can take the 75 and substitute into this A formula, which is what I'm going to do. I'm going to show you either way will work. What I'm talking about. Oh, but it didn't let me drag it. So, I'm going to take negative 3, parentheses, 75 squared, plus 450, close, 75, enter. And we get 16,875, and that's square feet. Let me show you another way to look at it. I could take that W and substitute it in here to find my length. So 450 minus 3 times 75. That gives us the length of 225. Now that I have the length and I have my width, which I write that down, I can just times that by 75. We get the same thing. So there's two different ways of finding the maximum area. The reason why I did that is because sometimes the question asks for the dimensions, and so that's how you find the dimension. And that's it. Let's look at this example. This is number 42 in the review. You want to click on the interactive figure. Before you do that, you want to show H of T and click the time play button to trace the path of the baseball. You want to find the domain, so the question is find the domain. So just click on that. Then you want to click on show H of T, and you'll see that we're at t equals 0, which is our x value, and domains are x values. So you click up here and hold down the mouse and drag it along, and you'll see that we're going to t equals 4.5. So what that means is the domain is 0 to 4.5. So when we go back over here, we just want to type it in. 0, 4.5. And check it. Nice work. So we're just using the positive values where the ball starts from when it's at t equals 0 and then to where it hits the ground. Now number 43, we are going to use the interactive feature to find when t equals 4 what the height is. So we're going to click there. We're going to click on show H of T. Then we're going to drag this until we get down here till where it's 4. And once we get 4, t equals, or h equals 36 is what we're looking for. 36, check it. Well done. And that was number 43. And then going to go to the next one, reload. And we're going to use the T slider to find all the times T, the baseball has a height of 64 feet. So we're looking for the H this time. H is 64. Click there. H is 64. So look, here's 64, so it's going to be about there and there. And let's see if we can find those values. So there's 1, 0.5. So I'm going to go back over here, type in 0.5, comma. And then I'm going to drag it again until I get to 64 again. There it is, and that's 3.5. 3.5, enter. And that's that.